Alright, so guys, so today we're going to do problem 7.19. Okay, so and it reads, two reservoirs have water levels differing by 8 meters. So you'll see here it says 8 meters. So that tells us that we're going to have to use Bernoulli's equation later on. The reservoirs are connected by a pipeline, of which the first is 2.5 kilometers, and the pipe is a pipe diameter of 500 millimeters. So the first pipe is 2.5 kilometers and it has a diameter of 500 millimeters. The pipe then splits into two parallel pipes, each of a diameter of 250 and 200 millimeters respectively, each 2 kilometers long, and connected to the lower reservoir. Assume the friction factor F for all the pipes and calculate the total discharge and the flow rate in the 200 millimeter pipe. Okay, so where do we start? So first of all, let's get a clean slate here. So we have to start with our picture of our problem. So first of all, we have a reservoir and we have a pipeline connected to this reservoir. And it says that this section is 2.5 kilometers long. So it means it's 2,500 meters. Yeah. Okay, so it's 2,500 meters, the first pipe section. So we can call this L1 is equals to this 2,500 meters. Then our second part would be the diameter. That's also information that we need to place on the figure. So we know that D1, our internal diameter here, will be 0.5 meters, and it splits into two pipes, each 2 kilometers long, so it's 2,000 meters. So let's do that. That's the first one, and the second one, we have them joining there, and both of them are 2 kilometers long. So we can say this one, let's get some information, let's call this L2. So this will be L2, and this one will be L3. What's the length of each? It's 2,000 meters. This one is 2,000 meters. And then the diameters, they tell us those are not the same. The first one, D3, will be 0.25. And that should be D2. Let's just see how easy is it to delete. It's just very hard to write. Okay, then D3, this one is 0.2 meters. Okay, and they tell us these are connected to the lower reservoir. So those two pipes, where they join, they are connected to the reservoir. So at this point, we have the reservoir connected to this part here. So meaning we have our reservoir lying somewhere here. Okay, and what else did they tell us? They told us we need to calculate the flow rate in the 200 millimeter pipe. So we need to calculate the flow rate in this pipe. So let's just number our pipes so that we know which ones we're working with. So you can call this pipe number 1, pipe number 2, and pipe number 3. Okay, so now we know what we're working with. So they want to know What's the flow rate in pipe number 3? Okay, and we have some more information with regards to the water levels. So we have our water levels in our reservoir. Well, we can keep it in blue. I'm sure it will be fine. So now we know that the water levels will differ by, they said, 8 meters. So there we go. Those two water levels, they differ by 8 meters. Okay, so now you've got your sketch done. You can maybe call this reservoir 1 and this one reservoir 2. Okay, so now you've got your sketch done. But we still need some other information as well. Remember, they gave us the friction factor as 0.009. So that's for all the pipes, basically, right throughout. Okay, so we don't really need to put that on the sketch, but if you want to, if you forget, you can write down what the friction factor is for each pipe. Remember, it becomes important to know which friction factor you should use for which pipe, because they might be different in the exam or in the test. So in this case, you're lucky, all 3 pipes, they've got the same friction factor. Okay, so we don't have to really worry too much. You can just maybe make a note and say friction factor for 1 is equals to the friction factor for 2, and that's equals to the friction factor for 3, and that is equals to 0.009. Okay, so now you've got basically everything you need to do this problem. So from the previous class, we know there's a rule when it comes to pipes in parallel. We have the 2 rules where we have Q in must be equals to Q out, right? And in this case, we know that the discharge in pipe 1, Q1, is equals to Q2 plus Q3. That we know. And we also know that if we had to manipulate this formula or zoom into Q itself, then we end up with A1 times V1 equals to A2 times V2 plus A3 times V3. Okay, and then we also know the rule of the head loss in 2 parallel pipes. We know that in this case our HF2, pipe 2, should be equals to the head loss due to friction in pipe 3. And if we break down this formula as well, so we broke down this formula and this one. So here we know we will have to use Darcy's equation because it's turbulent pipe flow. The water is turbulent. We can safely assume that it is turbulent. Unless I tell you otherwise. If I tell you the water flow in this pipe is laminar, then you will have to use Hagen-Pazzuli's equation. Okay, but in this case, we will use Darcy's equation, which reads the following. It will be 4 the friction factor for pipe 2 times L2 times V2 squared over 2G and D2, and that should be equals to 4 friction coefficient for the third pipe times the third length times our third velocity squared over 2GD 3. Okay, so that we know is true. So now we've got basically the foundation laid for this problem. So what would be the next part to do? So let's do it here on the side. So obviously we'll have to work out some areas. So let's take out our calculator and see what we will get. So the first thing you'll do is you'll calculate the areas. So you'll say area 1. What is the formula for that? It's pi d squared divided by 4, right? And this one will be d1, and you will get your answer for that as 0.196 meters squared. Okay, so you can get out your calculator and calculate as we go along. And remember, you need to store your values because you'll use it later on. So let's quickly calculate that. That will be pi times d1. What is d1? d1 is 0.5. Okay, and you store that value, shift store in A. Okay, so now you've got that value, you've stored it in A. You can do for the rest as well. And the second answer will be, let's calculate the second one. The diameter for the second pipe is 0.25. So again, you can use your and you should get 0.049. 0.049 and meters squared, and you store that in B. Now after that you can go to area 3 for the third pipe diameter, which will be 0.2. So let's calculate that one. And that one should give you 0.031 meters squared, and you store that one in C. So now you've got your areas. So we can now determine a relationship. So remember, we don't have the velocity in pipe 1, and also we don't have the velocity in pipe 3. So remember, we want the flow rate in pipe number 3. We look at our sketch again. We want the flow rate in this pipe. So we have to go and write a formula in terms of this. So the first one being where we say the head loss due to friction in pipe 2 is equals to the head loss in friction in pipe 3. This is what we already have down here. One you have here. So what you'll do is you'll input all the values that you have, that you've calculated, and all the knowns and unknowns, and you will sit with your first answer here being 14.679 V2 squared is equals to 18.349 V3 squared. Okay, so how do you get to that? You simply just go and take the 4 times the friction coefficient for number 2, which is 0.009, times the length of pipe 2, which is 2 kilometers, so that's 2,000 meters. Okay, so that part you have, and you divide it. You divide it by the 2 times the gravitational acceleration. Divide by your, in brackets, your 2 times 9.81 times D2, which is 0.25. And you will see you get to 14.6788. So you round it up to 14.679. Okay, so when you've done that, store those values as well. So you'll go and you'll store this value as well. So we've already used C, so we can store this in D. Store this value in D, and the same for this one. We'll store this one in E. Okay, so let's do that. Shift store in D. And let's do the other one. That one will be again in brackets of 4 times the 0.009 times the 2,000, because the length of pipe 3 is also 2,000, divide by the 2. So you can just go up in your calculators, it's memory, and just change the diameter of the previous equation. So the pipe 3's diameter is 0.2, and you will get 18.3486. So round it up, you get 18.349. Store that value, shift store in E, and now you've got those values too. So now what do? Now you need to go and write an equation for V2. So how do you do that? It's pretty simple. So we'll say that V2 is going to be, in simple terms, this. It's going to be the 18.349 divided by the 14.679 V3 squared, the square root of that, and that's a 1 there, 18. Okay, so let's see, what do we get? So you won't necessarily be able to calculate, remember you're writing an equation in terms of V2 and V3, so you shouldn't have the square root all the way. Let's just delete that. Let me just make a nicer one. So it will be the square root of, okay, it will be, you can write the square root, because we need to take the square away. We need to remove this square. So that's fine. So let's do it. So it will be alpha E divided by alpha D, and that gives you a yes 1.25, right? If you take that, now you take that 1.25 and you square it, so the square root of 1.25, and that gives you 1.118. Okay. So then, and also, so that's if you squared this, So the first, this in itself, before you squared it, will be 1.25. Then you take the square root of that 1.25, then you get 1.118. And if you take the square root of a square, then obviously you will only end up with V3. So we will end up with this 1.118 V3. And this will be your equation 1. Okay, so well done. So we have our first equation. Remember to store this value. Remember to store that value 1.118 because you're going to need it later on. So we'll store that in F. Shift store in F. Okay. So now we have that. So we still need to do some other calculation. We still need to determine what the velocity will be in pipe 3. So how will we do that? We can have a look at what we did previously. What's known? We know that Q1 is equals to Q2 plus Q3. So we can actually have something. We can create a formula here using this. So, and substituting our formula that we just made now, equation 1, into this equation. So let's see if I can just add another page here. So we already filled another page. Okay, so that brings us to the next part. So remember we said we will have to use the head loss due to friction. That formula we've used already. And now we have to use this one. Q1 equals to Q2 plus Q3. And we have our equation here, which is A1 times V1 equals to A2 times V2 plus A3 times V3. Okay, and we've established that, so this will be our second equation, our equation 2. So now what we'll do is we'll substitute equation 1 into equation 2. So how do we do that? So we know that equation 1, if we look at equation 1 again, I'm going to write it down here. It said that V2 is equal to 1.118 V3. So we're going to substitute that into this formula here. So we'll have A1 times V1 is equals to A2 times our V2, which is brackets 1.118 V3 plus our A3 times V3. Good. Now we have something we can work with. So let's see what we can do. We have the areas calculated, remember? So here we will have for area 1 0.196 V1 equals to area 2, which we have as 0.049. The bracket again, 1.118 V3 plus our A3, which we had as 0.031 times V3. Okay, so we can calculate this. This one will stay 0.196 V1 and let's multiply the 0.049. Remember, we stored that value, I believe, in alpha D. No. Which one was it? A B or an alpha B? Yes, alpha B, 0.049 times the 1.118 that we stored in F, I believe. Alpha F, and that should give you 0.055, and we can store that value in X. So I'm going to store this value in X on my calculator, and this will be V3 plus that will stay 0.031 V3. Okay, let's quickly see what we can do. So we've got this in terms of V3, so we can add these two values together. So you will take your alpha, or you don't even have to store that one in X, but you can. Let's store it, shift store in X. So we'll say alpha X, which is the 0.055, plus our 0.031, which should be alpha C. And then you should get 0.086 V3, and this side 0.196 V1. Let's scroll down. Okay, so now we have another equation. Or no, we still have to continue. We have to work out V1. Let's do it V1. So let's go and take the 0.086. You could have stored it again in Y, but I'm just going to use the value I have already on the calculator, and I'm going to say that divide by the 0. That should be alpha A, which is the area of the first pipe, which is 0.196, and you should get 0.439. You could have made it 0.40, but you could have left it this way as well. And this one you have to store, V3. So I'll store my value, this value here, I'll store it in Y on my calculator. So I'll say shift store in Y. Okay, so now we have a formula for, okay, this will be our which equation? Our third equation. So now that we have another equation, we also know now that the head loss, or the static head, in this case, for there to be flow, if we look at our pipe layout again, we have our reservoir, we have our pipe, we have two pipes, and we have our reservoir, another reservoir. Now there's a difference in the water levels of 8 meters. Okay, and that difference in the water levels is actually the static head. So, but for there to be flow from reservoir 1 to reservoir 2, for there to be flow, the head, the static head, which is 8 meters at this point, has to be more than the head loss due to friction. Okay, so remember we have head loss due to friction here in pipe 1. Let's use a different color. So let's use, for example, let's use green here. Okay, so we have pipe 1 here, and we have pipe 2 here, and we have pipe 3 here. So remember, we said that the head loss due to friction in pipe 2 and in pipe 3, that it's the same. We can't add them together and assume that is now the total head loss. We can't. Doesn't matter if the water flows from pipe 1 via pipe 2 to the second reservoir, the head loss would be the same as if you would go from pipe 1 via pipe 3 to the reservoir. Okay, so that means in essence that the static head, H stat, that total head we have, which is 8 meters, should be more or equal to the head loss due to friction in pipe 2 plus, no, sorry, wrong, that one's wrong. Should be 1, pipe 1. Head loss due to friction in pipe 1 plus the head loss due to friction in pipe 2 or 3. You could have used any one of those. Okay, so that's the next part, which is simple. So we'll end up with another equation again here, where we can now substitute those equations we've just managed to do into this last equation, which we have to write up, which will be equation 4. So let's quickly write down our fourth equation, which would be 8 meters is equals to the head loss due to friction. So it will be 4 F1 L1 V squared for 1 over 2G D1 plus our head loss due to friction for pipe 2, which will be 4 F2 L2 V2 squared over 2G D2. Okay, so that will be this will be our fourth equation, equation 4. Okay, so now we can do something at least here. So first of all, if we go and substitute equation 2 and 3, so need to substitute equation 2 and equation 3 into equation 4. Okay. So do we have both of them? Yes, we have equation 2. No, equation 3 we have to substitute. And where's the other one? We have V1 is equals to 0.439. So this one we have to substitute into that formula. And then also we have to substitute another one in there. I'm missing it now. It's probably the one where we have V1 and V2. So in equation 4, if we look at it, we have V1. Yes, that's the one that I didn't mark. Okay, so this one is also, this one forms part of, this one is our equation 2 from the previous page. Equation 2. Okay, so let's substitute those two equations into equation 4. So let's see, okay, so equation 1, let's write it down, equation 2, equation 2 is where we have our V2 is equals to 1.118 V3, okay, and equation 3, this is the one where we have V1 is equals to 0.44 or 39, which we had. So you can use the 40, doesn't matter, as long as you use your stored values in your equation, you will be fine. V, and this one is also in terms of V3. Okay, so remember our equation 4, which we have, is written in terms of V1 and V2. It's written in terms of V1 and V2. So we have to go and substitute these two equations into that formula, into that equation. So if we go and do that, we should end up with one unknown, which is V3, which will solve a lot of problems for us. So meaning we will only sit with this now. So let's try and write the equation out. So let's say our equation 4. So it will be the 8 meters equals the 4 F1 L1 times our V1, which is 0.0. Why do I like putting zeros in front of a 4? Okay, let's try again. 0.44 V3, close the bracket, and it should be squared. Divide by 2G and D1. And that should be added. Then we add our second head loss, the head loss due to friction in the second pipe. So this was for the first pipe. Now we're going to add the second pipe's head loss due to friction, which will be 4 F2 L2. What is V2 in this case? If we have to substitute, it's going to be 1.118 V3. Close the bracket, square it, divide by 2GD, in this case D2. Okay, so again, now you're left with the calculations you have to do to come up with a final formula in terms of V3. So you need to go and solve V3 in this case. So if you want to, you can go and let's do it quickly. So we'll take, it's going to be the 4 times F, which is 0.09, times, in brackets, the 0. I'm going to just use the values as is. I'm not going to use the stored values. Or let me try and use them. I think I would have stored that alpha E was equal to, no, it's not that one. E. I think it's maybe E. Alpha F. Okay, no, we'll just use the 0.440 as is, so that you can just see what is the process. So it's going to be 4 times F1 0.09009 times L, which is for the first pipe, our length is 2,500 kilometers. 2,500 times, in brackets, you have to put that 0.440 times V3 in brackets. So it's going to be 0.44 squared, close the bracket, and that will be times V3 squared. Okay, so we'll still have that. So all of that has to be divided. Take away the square by the 2g. All of that will be divided by 2g d1. Brackets. Just want to add another bracket on my calculator. So we have the 4 times the f times the l times the 0.44 squared. And we divide that put it in brackets, 2 times 9.81 times our d1, which is 0.5, and then we end up with this value, 1.776 V3 squared plus the second one. I'm going to store that value so I don't forget it. So I'll have, in this case, I'll store it in A. Shift store in A. And the second one I will have, again, we have to calculate. So you can use your stored values in your calculator or the stored equation. So it will be 4 times the F, 0.009, times the length 2 of pipe 2, which is 2,000 meters, times brackets again, that 1 point should be the 1.118 squared, divide by 2 times g times d2. So we have to change the diameter of d2, which will be 0.25, and that should give you 18.348 V3 squared. And that's 8 meters. You don't have to write the meters there in this, just so that you're reminded that it's the static head. So now we're left with this. Now we can simply solve for V3, right? So we can simply solve for V3. Should be easy. So let's see. Now I'm going to store that 18 so we can use it. Shift store in B. So what do? We can add those two together, which we have as alpha A, which is the 1.7 plus alpha B, and it's more or less 20, so it will give us 20.124, so it will be the 8 divide by, remember we're taking all of this to the other side, so it's going to be the 8 divide by, in brackets, which we have the 20.124. Okay, so it's going to be whatever you've added these two together, we will have 20. So this would have been, and this will be squared as well. So this would have been 20.124 V3 squared. Okay. So then if we go and take the 20, 8 divide by the 20, then we end up with the V3 squared is equals to this. And what does that equate to? So we can say 8 divide by the 20, which is alpha C, and you should get 0.398, more or less. Now that's not the velocity yet, so we have to square it. So let's square both sides. We square both sides, what will happen? Then we will end up with V3 being equals to what? In meters per second. So let's see what will happen. Let's square that value. Shift, store in D, this one, and I'm going to square it. Alpha D. And if we've done that, you should get 0.6305. Okay, easy. And that's basically the last thing that you had to basically calculate that's difficult. Now the only thing you'll do now is simply go and substitute V3. So now you'll go and you'll substitute V3 into equation 2, 3, 2 and 3, and you'll calculate the velocities for those. So remember, we have equation V1 here in terms of V3, and we also have V2 in terms of V3. Okay, so then you can calculate the velocity of the first pipe and the velocity in the second pipe by just substituting in the values of 0.6305 meters per second. And then what can you do then? You can simply calculate the flow rate, where you can use Q is equals to A times V for each case. And that's how you solve this problem.